Good morning everyone. I hope you are doing good. And once again, welcome to the Shri Chaitanya Goshala YouTube channel. And this is Amit Bhardwaj, and today we will try to solve those questions in physical chemistry which are most expected in the NEET exam, right? And we will revise little concepts also with these questions. I hope you will get benefit from this, right? Let us start with this. So, first question we can see here. The question is maximum number of molecules are present in. So, definitely this is related to the mole concept chapter. Let us see. So, to find number of molecules, I have to convert volume or weight, or you can say number of particles into what? Moles, to compare the number of molecules present here. Like in first case, if I say I have 15 liter of H2 gas, so how I can find the moles? 15 divided by 22.4, right? Third formula, given volume by 22.4, and condition should be STP, right? They give STP only. To get the molecules, I will multiply by Na, right? In the next case, if I say I will get 5 divided by 22.4 into Na, number of molecules they are asking. Similarly, here 0.5 gram they give this time. So 0.5 gram divided by 2, because it is weight, na? Weight divided by molecular weight or molar weight, I will say, right? Into Na. And here they are saying 10 gram of O2. Here they are saying 10 gram of O2, right? So 10 gram O2 means 10 divided by how much? 28. It's 10 by 28, so many moles into Na, number of molecules. So last two formulas are telling us to use weight by molar weight, and these two giving by what? Given volume by 22.4. So from here you can see in which case we are getting the maximum number of moles, right? If we think here the moles will be more than half. Moles will be more than half, that's why molecules will be more, right? Okay. Next one, we can say the first one. Next one is the number of water molecules present in a drop of water. Here students make which mistake? Let us discuss first. Actually, the third formula, or I will say the formula volume divided by 22.4. We can apply this formula only for gases. We can't apply this for the liquids, or if they gave volume of something. It is applicable only for gases and at STP, or you can say NTP condition, right? They are saying water in a drop of water. Definitely drop of water they are saying means it is liquid state of water. Can you find the weight? Yes, weight is volume into density. So what's volume here? 0.0018 ml, and density of water how much? 1. So I can say we have 0.0018 gram of water, right? So we can find the moles and then molecules. How we can find mole beta? You see if I write it this way, it's 18 into 10 to the power minus 4, and the molar mass is 18. So from here we are getting 10 to the power minus 4 moles of water. And if you want to find water molecules, then it's very easy. How we convert moles into particles beta? So 10 to the power minus 4 moles into Na, right? You put the value, you get the answer. If Na is 6 10 to the power 23, so minus 4 is coming, so almost how much? 19 will come if you solve this out, right? Again, on the basis of mole concept, formulas of mole I will say, right? We discussed about it in the revision section also. Just to tell you little point, how to get mole. Weight divided by molar mass, we get moles. Volume divided by 22.4, but we get moles. And this is only for gases. Be careful. At which conditions? NTP. And if they give us number of particles, so what we do? We divide number of particles by Avogadro number to get the moles, right? This way you can do these type of questions, fine? The next one. Now this question belongs to the limiting reactant topic, right? What they are saying here? 4 mole ammonia, 5 mole O2, it is stoichiometry. They are saying 1 mole of O2 made to react completely with, okay, both 1 mole. So they are saying I am taking ammonia's 1 mole and O2's 1 mole. First of all, our target is to find which is limiting reactant. How we find? What is shortcut, beta? Shortcut is given moles. Whatever moles are given moles divided by stoichiometric coefficient. For every reactant, I will find this. Given moles divided by a stoichiometric coefficient. Whatever number give me least value will be our limiting reactant. Like here, 1 mole is given, divided by 4. For O2, 1 mole is given, divided by 5. So this is smallest number. This is small, right? Least number. So from here I can decide it is O2, which is our limiting reactant. Now limiting reactant we have found. Now limiting reactant will decide how much moles of product will form. Okay, be clear. Always limiting reactant decide how many moles of product will form, not the excess reagent, right? 5 moles make how many? 4. So limiting will become 0. 5 make 4. So beta 1 will make how much? 4 by 5. What's the point? So it's 4 by 5 mole will form. 5 mole make 6. So 1 will make how much? 6 by 5. These are moles of NO and water formed. It's some moles will left because it is excess reagent, right? Fine. So you can find from here what they are saying. 1 mole of H2 is produced? No, it is 6 by 5. 1 mole of NO will be formed? No, 4 by 5. All ammonia will be consumed? All ammonia will be consumed? No, it is excess reagent. All the oxygen will be consumed, right? Because oxygen is the limiting reactant. Okay, so you know the shortcut how to find limiting reactant or limiting reagent, right? Now the next thing is a compound contains, this is the mass percentage given. Okay, last year also and last year also they asked question from here. We can see here now they gave 3 elements. Our compound is made up of 3 elements: carbon, hydrogen, oxygen. They gave us weight, right? What is the weight given? 30. They gave carbon how much? They gave 54.54. Hydrogen is 9.09, and oxygen 36.36. Right? We have to find the molar ratio. How we can find 54.54 divided by how much? 12. 9.09 divided by how much? 1, and 36.36 divided by 16. So our target is to convert weight ratio into molar ratio, right? So from here if you solve it, it gives us almost 4.54, from here 9.09, and from here if you see what is coming, it's coming almost 2.27, fine? So which is smallest number? Out of these if I see it, it is smallest number. Divide this and every number by the smallest number, gives you 1, gives you 4, gives you what? 2. The formula is what? C2H4O1. We can see, yes, C2H4O1, right? This way, just they will give the mass percentage divided by molar weight, and you will get what? You will get the molar ratio, and the molar, simplest molar ratio give you empirical formula. That's it. Easy question, right? Okay, the next one we will see. Fine. The next one is, if the concentration of glucose they give in the blood, what will be molarity? Okay, so be careful. There is one term, if you remember, it is strength. Actually, strength is weight of solute per liter of solution, so gram per liter. Whereas if you see the molarity, there is one more term, molarity, very important term. It is number of mole of solute divided by volume of solution, right? So I can say it is mole and it is what? Liter. But here they are saying it is gram per liter. So how we can convert strength into molarity, right? So it's very easy, beta. It is given 0.9 gram per liter. Just I will divide by what? I will divide by molar mass of this C6H12O6. So how much they gave here? They gave 180, and per liter is fine. So you can convert strength into molarity. How? If you divide strength by the molar mass of solute, okay, you can convert strength term into molarity. That's what I'm doing, 0.9 by 180. You can solve this easily. If you see, we can write it what? I can say it is what? 900. So we'll take it 10 to the power minus 3 and divide by how much? 180. So from here, how much coming? 5 10 to the power minus 3, or you can say 0.005. Fine, easy. Again, I'm saying molarity is strength of solution divided by molar mass. This relation you can remember to do the direct questions, right? The next one, if I say, okay, now they are giving us question in which they are relating the weight by weight percentage with the molarity. Again, we have a short formula. These relationships are very, very important, okay? So I am saying here the molarity I am finding. Okay, the density they have given for this molar sulfuric acid, that is 29% sulfuric acid by mass. They are asking density. So we have to write the relationship molarity is equals to 10 into weight by weight percentage divided by molar mass of solute, and in the question they are asking density. This is a complete relationship, density of solution, right? In the question they gave us molarity, it is 3.60. It's 10 weight by weight. How much they gave it? 29%. What is the molar mass of solute? It is 98 sulfuric acid, and here we have the density which we have to find, right? Nothing tough here. You have to just solve it to get the density value. I'm saying once again the relationship. What is the relation again? The molarity is 10. Okay, we have written this. One more relation I am writing, 10 into weight by volume percentage divided by molar mass of solute. When they give weight by volume percentage, there is no need of density in the formula. But when they give weight by weight percentage, we need density. Why? Because in molarity, volume will come as a term, right? So we have to convert the weight into volume. So here density will come. In this case, there is no density, right? Good. The next thing, the first emission line of hydrogen atomic spectrum in the Balmer series, right? Balmer series means, first of all, the Balmer series means our spectral line will end in the shell number 2. It is Balmer, Lyman, Balmer, Pasteur, bracket, P1. So it is N1 is 2. First line means just jumping from one above. First line. So I will say it is jumping from where? It is jumping just from one above, that is 3. So our electron is coming from 3 to 2, and the radiation emitted will make spectral line. For that we have to find what? They are asking us the okay. They are asking the wavelength or wave number, sorry. So what is the formula of wave number? Wave number is R 1 by N1 square minus 1 by N2 square. So R is here we are having 1 by 2 square and 1 by 3 square, right? If we solve a little bit, what is coming from here? 9 will go here, 4 will come, so 5 R by 36, right? You can solve this easily, okay? Let me tell you one more thing. First line means you are jumping just from one above. If I am saying second line, you are jumping from 2 above. If I am saying 10th line, so you are jumping from what? You are jumping from 10 above. And if I am saying limiting line, you are jumping from where? Infinite. You are jumping from infinite. So be careful about it. First line means jumping just above. Like for Balmer, 3 to 2 is first line. Whereas for Balmer, if I say, what is the infinite line? I will say, what is the limiting line? I will say, infinity to the Balmer means 2. Okay? Okay, base you can decide, the element you can decide by the which series it belongs. And first, second, third line you have to add something in the base number to get the higher N2 value, right? Okay, that's it. Now, the next thing is the radius of first Bohr orbit they gave A0, then the radius of the third orbit. Okay, fine. In the Bohr model, we have seen the formula for radius. It is A0 n square by z. Okay, this A0 you can say for the first orbit radius, that is 52.9 in picometer you can say. So this is A0. A0 I am taking here n square. N square means they are saying third orbit means 3 square, and hydrogen atom definitely it is 1. So So what's coming from here? It's 9a naught, right? Easy to find. Clear? Or sometime they give you radius of one shell, they ask you radius of other shell. In such questions, always use this one. R1 by R2 is equals to N1 square by Z1 divided by what? N2 square by Z2. Like in this question also, if I say they gave me A naught. A naught is the value of which shell? First shell in hydrogen atom, and they're asking us radius of hydrogen atom's third shell. I will take what here? Third shell means 3 square and hydrogen atom. So from here, if I say hydrogen atom third shell, it is how much? If you solve this thing, what is coming from here also? 9a naught. Okay. Here they gave me first shell, so I know it's very directly, but if they give something else, you always go for ratio. It is easy to solve this way, right? Now, okay, even if energy comes, you should go this way. They gave energy of one shell, they ask energy of other shell. So E1 by E2 is how much? I will say it is Z1 square by N1 square divided by Z2 square by N2 square. And similarly, the velocity V1 by V2 was how much? You can say Z1 by N1 and Z2 by N2. Fine? So easily you can go through this way, right? The next thing is in Bohr model of hydrogen atom, when electron jump from N3 to N1, how much energy will be released? If you see beta, if we have to find delta E, right? So what is delta E? In joules if I go, it is 2.18 10 to the power minus 18, right? And 1 by N1 square here. So what they are saying? Jumping to 1 from which shell? Third shell. And definitely they are saying hydrogen atom. So Z scale is 1 only, right? So you put this value, get the answer. So from here, 2.18 10 to the power how much? Minus 18. And if you see here, you can solve this thing. 9 here, 1 here. So how much? 8 by 9. But remember, it is in joule. You can convert easily joule into earth, right? Okay. The next thing, if I say correct set of 4 quantum numbers for the valence electron of, they are saying Z37. Okay. Let us see how we can write it. It's argon 18, 4s2. We are having here how much? 4s2, 3d 10. It's 30. Now if you go further, it's 4p6. Okay, 36. But remaining 5s1, right? Or I can directly say it is what beta? It is krypton 5s1, right? So you can go this way. If you see which element actually it is, look, it's hydrogen, lithium, sodium, potassium, rubidium, right? So they are talking about rubidium. So now 5s1. So from here we can see clearly that what is N value beta? N value is definitely 5 fifth shell. What is L value? S subshell, so 0. In L0 always M is what? 0. So S can you take plus half. So which any option absent? 5, 0, 0 and plus half. That's it. Easy to find, right? Okay. Quantum numbers are very, very important topic. So be careful about this question. Practice more and more questions from this topic, right? The next thing I am saying, which one among the following 4 will have the highest energy? Highest energy, right? First of all, if we discuss for one electron system, for hydrogen or one electron system, energy depends on N only. So I will say higher the N value, higher the energy. There is no use of L. Whereas if I say for multi-electron, if I say for multi-electron system, in that you will see there is formula N plus L. Higher the N plus L, then energy will be high. So N plus L, sum will decide energy, right? If N plus L is same, then I will go for N, so higher the energy. But first of all, you have to apply N plus L rule for multi-electron system, right? In this case, if I say, are they mentioning hydrogen atom? No, they are not mentioning. So by default, I will take multi-electron. For hydrogen, they will mention specially, right? So here, let us see which have the maximum value of N plus L. So here N plus L how much? 5. Here N plus L how much? 6. Here how much? 5. Here how much? 5. So here you can see clearly N plus L is maximum. 4 plus 2, 6. That's why higher the N plus L, higher the energy. And if you say it is which shell beta? Which subshell I will say? 4th shell. And 2 means which one? D. It is 4D subshell or some orbital of 4D. Right? That's fine. Okay, fine. Easy to find. The next thing is delta H and delta U for the formation of carbon monoxide. They are asking the difference of delta H and delta U. We know very well the relation between delta H and delta U. The relation is delta H equals to delta U plus what? Delta NGR. Define this relationship. So first of all, let us write the reaction here. Formation of carbon monoxide. Okay, we are making carbon monoxide. CO. CO is a gas. How we make it? From simplest constituent, carbon and half of O2. So carbon to solid and O2 is a gas, it is also gas. So what is delta Ng coming from here? Product gas moles minus reactant gas moles, right? So how many? Product gas mole 1 and reactant gas mole how much? Half. Right? So what's coming finally? So finally it is coming, okay. So finally it is coming how much? Delta Ng is coming only plus half. So delta Ng is coming plus half, right? So we will use it. Okay, fine. Okay, which whatever it is. So what was there in the previous slide? So you can see they were asking delta H and delta U. So it was coming delta Ng RT. So delta Ng value how much coming? 1 by 2. Because here 1 gas mole, here half gas mole. Half is coming. RT, if they are saying in kilojoule, so what I will say? R value 8.314 10 to the power minus 3 in kilojoules. And whatever temperature they are saying, you can keep temperature there to find the difference of delta H and delta U, right? Delta Ng RT. So easy to answer. Now the next question is ideal gas expand. Now it is coming from thermodynamics. What is the question? An ideal gas expand in volume from this to this against a constant pressure. Okay, they are mentioning specially against a constant pressure, means it is irreversible. This point is telling us that it's an irreversible process, right? For the irreversible, how we find the work? W equals to minus of P external delta V, right? So what they are saying? P external minus P external 1 10 to the power 5 Pascal they are saying. SI units, good. Delta V is expand they are saying 10 to the power 2 is the final, means and here 10 to the power 3 initial one. So you see, you can get delta V from here and you multiply it here. What's coming? It's meter cube directly. So minus 10 to the power 5 here, and if you write it, what is coming? 10 to the power 2. It's minus 2, sorry, it's minus 2 and how much here? Minus 3 meter cube they are saying. So I will say 10 to the power minus 2 means how much? 0.01 and how much here? 0.001, right? So you can just apply the formula minus of P delta V, right? Easily you can get the answer. If by chance they ask reversible process, I'm saying once again, if they ask reversible process, right? So in reversible process, how we find? The work formula will be a little different. It's minus of 2.303. It's a nRT log how much? V2 by V1. Okay, you can call this nRT as what? Sometimes you can call it as PV. Maybe they give you P1 V1 also, P2 V2 also. Any of these you can take. And this V2 by V1 can be used as P1 by P2 also. Right? So any of these you can go, right? It is for irreversible, it is for reversible. Fine, easy. Very important topic from the NEET point of view. Work done questions, right? The next thing, 2 mole of ideal gas expanded isothermally and reversibly, right? They gave just now this question. They are asking beta, they are saying isothermally and reversibly from 1 liter to 10 liter, right? The enthalpy change. They are asking enthalpy change, means they are asking about delta H. First of all, we have to be careful, they are not asking work done from us. If just work done, we can apply the backside formula, isothermal and reversible. But in the question, you be careful what they are asking. They are asking in the question enthalpy change, and they are saying temperature is constant, no change of temperature, and delta H is what beta? It is NCPM delta T. So if delta T is 0, then definitely delta H also 0. No need to waste time. If it is isothermal process and there is no expansion or there is no if there is no reaction, I am saying, in an isothermal process, if there is no reaction going on, no phase change, just expansion or compression, so in such case delta H as well as delta U both will be 0, right? So here it is isothermal process, so delta T is 0, so delta H also 0. Similarly, by chance they ask delta U, so it is what? It is NCPM delta T. So this also, if it is isothermal, delta U also 0, right? But if reaction is happening or phase change happening, in that case, even if temperature is constant, delta H and delta U will be non-zero, right? Even like imagine I am vaporizing liquid, H2O liquid becomes H2 vapor at 100 degrees Celsius. Temperature remains 100 degrees Celsius, but definitely there is delta H also and delta U also, because in that phase change happening. Similarly for the reactions also you can say that, right? This thing I can say only when gases are just compressed or gases are just expanded in isothermal conditions, fine? Okay. Now the next question is from Hess law, right? What they are saying, they want to make this equation, third equation, using the above two, right? So how we can make? For this type of question we have to follow a simple rule: what we need, how much we need, and on which side we need. What we need, right? So look at this, what do we need? Fe2O3. In above two reaction, where is Fe2O3? In first reaction, okay, first circle this reaction. I need one Fe2O3. I need only one Fe2O3. In this reaction, how many Fe2O3 given here? One only. So 1, same. I need left side, here also where? Left side. So no need of flipping, no need of multiplication, just as it is, I will use it as it is, delta H1, right? I need CO. CO is part of this section or this section also. If CO is present in both the reactions, then leave it. If something is present in both the reactions, leave it. In our trick I am saying. Now go to the next one, FU. Where is FU? FU is part of second reaction, right? I need 2 FU, here how much only? 1. I need right side, here they give left side. So flipping required as well as multiplication. Flipping because I have to convert the side. Here I need on right side, but here on left side. So flipping required. Second thing, here I need 2 moles, and here how many moles are given? Only 1 mole. So multiplication also required, right? So now I have used both the equations. It's enough for us. So delta H3 is what? Delta H1 minus of 2 delta H2. This way you can apply the formula to get the answer. Now we can see very clearly the values they are given, minus 26.8 and minus here 2. What is delta H2 here? Delta H2 is how much? Minus of 16.5. Remember, this minus is coming because of operation we are applying. The value of delta H1 is minus 26.2 and value of delta H2 how much? Minus 16.5. Don't miss this minus here. Okay, this minus is coming because of relationship. Okay, good. It is simply Hess law. Hess law, simple question. Good. Now, this question is from the NEET exam only. 2 times same question in the NEET exam without data change, right? So what we have here? We see carefully. We have to make xy. I am making xy. This is xy we are making. From where? We are having x2 and we are having y2, right? So we will take here half of x2 and we take here what? Half of y2. And for this reaction, they give the delta H value is how much? The delta H value is minus 200. It's minus 200, right? If they give us bond energy of different reactants and product in a given equation, I can write this relationship. So delta H of reaction is summation of bond energy of reactants and minus summation of what? Bond energy of products, right? So first of all, they gave the bond energy of xy, x2 and y2 is which ratio? 1:1.5. So I am calling it like here. This is bond energy. They gave for xy. Here they gave xy. Here they gave x2. And here they gave y2. And in the question they are asking for x2, right? Imagine for x2 they gave ratio, na? They gave ratio 1:0.5. If I will take this as x, imagine it is x. So it is how much? X by 2. It is how much? X. Bond energy I am assuming like this, right? Now what we'll do? We'll put the here bond energy of reactants. Reactant means half of x2. And for x2 bond energy how much? X only I am considering. And half of y2. For y2 how much? X by 2. Minus, I will say bond energy of what? xy. Bond energy of xy how much they gave? X only, right? We put whole this thing equals to how much? They gave delta H value minus 200, right? From here easily we can get about x value, right? Even if we solve it, it is minus 200 here. It's x by 2. It's x, and here how much beta? It's x by 2 coming. Here x by 4 coming, right? And here coming which value? It's coming minus x, right? Let's just solve it to get the value of x, right? Clear? Easy. Okay, the next thing is characteristics of equilibrium constant. Again, very easy. You see carefully, they have given us one equation, a plus 2b give 2c, and here they are asking for c and b plus half a. How I can make the second equation from the first equation, right? What I will do? A plus 2b give 2c. So they are reversing the reaction and dividing by 2. If I reverse the reaction and divide by 2, then I will say reversing means what? 1 by kc, and divided by 2 means what? Power 1 by 2. Reversing make the equilibrium constant 1 by, means reciprocal, and dividing by 2, or you can say multiplying by 1 by 2 will make it power. So what's coming here? What is the value of kc they gave for initial? So 1 by 40, and how much here? 1 by 2. So you can say from here it's 1 by 40 power 1 by 2. Fine, easy. Relationship they gave always, right? If I show you a little bit point here, imagine I have a reaction, it's AB, and its Kc value imagine given as x. So if I want to write the Kc for this reaction, Na giving Nb, so what's Kc here? Kc will be x power n. If I am doing this thing, 1 by Na giving 1 by Nb, I can say I am multiplying by 1 by n. So power become what? X power 1 by n. And if I reverse it, if I say B is giving us what? A. So what's Kc here? Kc will give us what? 1 by x, because we are flipping it. So these four are the operations, right? And one more thing if I say, if I have, imagine I have equation AB, its Kc is K1, and here one more equation CD, and its Kc is how much? K2, and they are asking Kc for this equation, A plus C giving us what? B plus D. We want its Kc. How we can get its Kc beta? We just add above two equation to get third equation, right? So if you add equations, the equilibrium constant will multiply. So I will say K1 into K2. So you can get the K3 or Kc using first two equations. If you add two equations, you just multiply them. In delta H questions, we were just adding like delta H1 plus delta H2, but here we have to multiply. Both have different operations, equilibrium constant and delta H. Fine? Okay, good. The next thing, look at this. Check out. Look at the question. Just 1 second. Fine. Okay. The value of Kp they gave for the reaction. The value of Kc they are asking. Fine. Easy question. Kc Kp relationship very important. If I say Kp is equals to Kc RT power delta Ng. Right. The Kc value they gave to us. The Kc value they are saying it's 1.2 10 to the power minus 2. Right. When they are not mentioning any units, so we take Kc in mole per liter and we take pressure in atm, or you can say bar, approximately same. So R unit will be simply 1 by 12 I can say over 0.0821. T they gave 1065 degrees Celsius. You have to make it Kelvin. How? You will do 273 plus what? 1065. So whatever come from here, you have to just keep this temperature here. And the next thing is you keep temperature here. What is the value of delta Ng I need? Na? Here I have 2 gas moles. Here I have how many gas moles? 3 gas moles. So 3 minus 2. So how much coming? 1. So easy to find, right? It's a very big number, definitely. So 1 by 12. Overall here number will be more than 1. So if you multiply with this number, definitely Kp is coming what? More than Kc. So in this question, Kp will come more than Kc, because if you total solve the value, T is very high, na? So you can say Kp is more than Kc. Easily you can answer from here, right? Good. The next thing is PCl5 is dissociating up to 50%. The total pressure they gave at equilibrium, right? Okay. So what is the reaction? The reaction is PCl5 is dissociating. Fine. In such questions, when nothing is given initially, so take 1, 100. Up to the time of equilibrium, it is dissociating 50%, means alpha how much? 0.5. So 1 into 0.5 is gone. How much remaining? 0.5. 1 makes 1, 1. The 0.5 is finishing, makes 0.5, 0.5. So easily you can see the mole fraction. The mole fraction can be how much? 0.5 divided by 1.5. So 1 by 3, 1 by 3. And the partial pressure, if I ask here, it's mole fraction into total pressure. Dalton's law of partial pressure, right? Now you have all the values of partial pressure. You can just apply here Kp expression. What is Kp expression? Pressure of PCl3 into pressure of Cl2 divided by what? Pressure of PCl5, that is P by 3. So from here we get the P by 3, right? What is the point? So you can say that from here P equals to what? 3 Kp, right? This one. Okay, right? Good. Next thing, if you look here, the Henry law constant for the following gas at 298 Kelvin are given. Okay, last year's NEET question where many students made a mistake. We discussed this very clearly that if Kh, Henry constant of a gas increase, the solubility of gas decrease. The solubility of gas decrease, right? First point. And if temperature, you see beta, if temperature increase, remember the Henry constant of gas increase, and then also I will say what? Solubility decrease. Here I am talking about if I am comparing 2-3 gases. 2-3 gases are given at same temperature and they gave their Kh values. The gas with higher Kh value will have lower solubility. Like helium gas have the highest value of Kh, so lowest value of what you can say? Solubility. Fine. Whereas if we talk about same gas but at different temperature, so higher the temperature, higher the Kh, lower the what? Solubility. Fine. Got the point? So in this case you see they gave the values here. Fine. So which of these is most soluble? I have to check which of these have the lowest value of Kh. Okay, the Kh value is lowest here, 1.83 10 to the power minus 5. Right? Very less value of Kh. That's why maximum solubility. Clear? What mistakes students made last year? actually what they were writing, they write like this one. These three gases have this pressure, these have kh value, 2, 5, 8 kilobar. Remember, if they are writing units in the end of something, that means it is unit of all. Like I am saying, there are 3 persons, first have weight of 40, like there are 3 persons having weight 40, 60, 70 kg. So means they are trying to say that weight of every person is kg only. So it is 40 kg, 60 kg, 70 kg. If they are not writing units here, it does not mean it has some other units. If they are not writing units here and they are writing units in the just last number, so you take unit same for all of these. Many students made this mistake because what they said in the question, how they wrote this kilobar. The students were thinking kilobar is a unit of just last kh value. No, it was a unit of every kh value. So be careful about it. Okay. The next thing is the number of angular nodes for 5p. Okay. What is the formula for angular nodes, beta? There are 2 types of nodes. First, I am writing for angular node. Angular node formula is what? Just L. Whereas if you go for radial node or spherical node, the formula is n minus L minus 1. And if I ask the formula for total node, but how much coming? It is coming, you add up both, what's coming? N minus 1, right? They are asking in the question that, they are asking for the 5p. For 5p, what is the L value? P have how much L value? 1. Okay, L value is 0 for S, 1 for P, 2 for D, 2 value for D subshell and 3 value for F. Definitely from here I can say P they are saying, so how much? 1, right? Good. The change in volume when 50 ml of O2 is completely converted into ozone. Again, a stoichiometric question, small question. What do we have? O2 converted to ozone. So initially they said I am taking 50 ml, right? Finally, after the reaction completion, definitely becomes 0. If they are not saying it is having equilibrium or something, so I will just convert, my reaction becomes 0 and product will form. How much it will form, beta? Check. 3 moles make how many moles? 2 moles. So 1 will make how much? 2 by 3. So 50 will make how much? Into 50. So what's coming from here? 100 by 3. So how much coming? 33.3. In liter also, if I say ml also, it was 50 ml here. 50 ml finish and make how much? 33 ml. So initial volume, if I say total initial volume was 50 ml, whereas final volume is how much? 33.3 ml. Fine. So 50 and 33.3, you can see how much decrease? Almost 16 point something, right? So volume decreased by how much? 16.67 ml decrease, because initial more, final less. Okay, this way you can go. Next thing is they are asking the oxidation state. So very easy to find. We know very well. If you go for HClO4, beta, H hydrogen is 1, Cl is X, oxygen how much? 4 into minus 2 equals to 0. Definitely you find X coming how much? Plus 7. HNO3 again 1, nitrogen X, 3 into minus 2 equals to 0, right? X coming what from here? Plus 5. As to the 4, 2 beta for hydrogen, sulfur how much? X, 4 into minus 2 equals to 0. X coming how much? Plus 6. S2CO3, 2 into 1 for hydrogen, carbon X, 3 into minus 2 equals to 0. So simple. There is no peroxide linkage or something. That's why it is easy to give the answer. And as they are saying, match the following, so we can see. HClO4, Cl how much? Plus 7, nitrogen, plus 5, sulfur, plus 6, carbon plus 4. And in the physical chemistry, definitely you see many questions come this way. They are not numerical. They are not numericals, beta. Easy part. Out of 45 questions in the NEET exam, 15 will come almost from physical chemistry, and out of 15 also I will say max to max 7 to 8 numericals can come. From physical also 7 to 8 theoretical question comes, conceptual questions, right? Legally principle or theoretical question where you will not be need to touch the pen. Okay? So out of total 45 questions, only 7 to 8 will be numerical. Remaining 35, 36, 37 will be just theoretical questions, conceptual question directly, right? Okay, good. Now the next thing is the expression for the Heisenberg uncertainty principle. Okay, so what is that? This principle says that we cannot find the exact position as well as exact momentum of a particle. There will be uncertainty. If you want to decrease the error in the position, the error in momentum will increase, right? So we know relationship very clearly. Delta x into delta p will always be more than what? H by 4 pi. Or if I modify this little bit, so delta x into what? Delta v is more than equals to what? H by 4 pi m, because delta p is what? M delta v. So in that we can go. Easy questions. The Van 't Hoff factor for the ethanoic acid in benzene. It's a very important question. Ethanoic acid in benzene. Be careful, solvent is benzene. So it will dimerize. Ethanoic acid dimerize because of hydrogen bonding. If something dimerize means it is associating. So always, in case of association, always I is what? Less than 1. If they give alpha, then I can apply the formula also. It's 1 minus alpha plus alpha by n. But I think they are not giving alpha. So just we have to use common sense that I association always less than 1. Only one option is present, 0.5. Right? Sometimes they give the I value, they want to ask you the extent of association or dissociation. So imagine, here I they gave 0.5. Imagine I just making a new question here, 1 minus alpha plus alpha by 2. So from here you can find alpha also, right? And why I am taking 2 here? What is n? N is number of particles which associate to make one particle. Like 2 ethanoic acid molecules combine to make 1. So 2 are combining, na? 2 are associating with each other to make one particle. That's why n value is 2. And I is always less than 1 for association, I is more than 1 for dissociation, and I equals to 1 when there is no association and no dissociation, right? Okay, fine. The next thing is osmotic pressure of 0.1 molar aqueous K2SO4, 50% dissociation they give. Okay, here we can use our formula. I can find I first of all. Again 1 minus alpha plus an alpha for the dissociation. 1 minus alpha. What is alpha? 50%. So 0.5 plus K2SO4 gives us how many particles? 3 particles. So 3 into how much? 0.5. So overall what is coming from here? It's coming 1.5. 1.5 or 2? 2 is coming, right? So I value is coming 2 if you solve from here. 1 minus 0.5, 3 into 0.5, so how much coming? 2 coming, right? Now we have to find the osmotic pressure. Pi equals to what? I CRT. Pi equals to I CRT. I value how much? 2. What is C value now? C value is 0.1 and R value. In ATM if I am using, so I will use R value almost 1 by 12. And T value how much? It is 300 Kelvin, right? 27 degrees Celsius I will use in Kelvin, right? So almost how much you solve? It is coming how much? 25. 25 to 50. 15 to 0.1. Almost how much? 5 almost we can say. Or very close to 5 is 4.92. Why? Because I am taking R 1 by 12 approximation. Actually R value, if you say in joules, it is 8.314. To make question little short, I use it as 25 by 3. In ATM, you use it 0.0821 or 831. So we can call it 1 by 12. In calories it is how much? 1.98 almost. So we take it almost how much? 2. Approximations little, give us little like different answer, very little, but it will save some time. Avoid lengthy calculations, right? So you can use it. Now the next thing is the mass percentage of oxygen in the CaCO3. Simply we have to do what? I want to find percentage of oxygen. If you see in its total weight, calcium is how much? 40, carbon how much? 12, and oxygen how much? 48. Total coming how much? 100. But carbon only 12. So 12 gram is the carbon weight in how much? 100 gram of compound into 100. Definitely how much coming? So they're asking which one? They're asking oxygen, right? Carbon is 12%. Fine. But they're asking oxygen. Okay, fine. Wait. Okay, so what are they asking? If I want to find percentage of oxygen, so I should take weight how much? 48 divided by 100 into 100, na? Previously we found the weight of carbon. Carbon was 12%, oxygen how much? 48%, and definitely the remaining part is what? Your calcium. 40% carbon, calcium, sorry, 40% calcium, 12% carbon, 48% what? Oxygen. That's it, fine. Easy. What is the formula? Weight of that element divided by total weight into 100, right? Like in case of glucose, if I ask, I have C6H12O6. I want to find percentage weight of carbon. So how much? We see, observe 6 into 12. 12 into 1 for hydrogen and 6 into 9, 16 for oxygen. Total how much coming? 180. So 72 is the carbon weight out of 180 into 100. So easily we can solve it. What's coming? 18 into 4. So almost 40%, right? Easy. The H atom, number of Degenerate orbitals in the second shell. Hydrogen atom is, if you see carefully, it's a one electron system. In hydrogen atom, energy depends only on shell number. It does not depend on the L number, right? It does depend on N value, right? So if you go in hydrogen atom, energy sequence is a little different. 1s, okay, 2s, 2p have same energy. Then 3s, 3p, 3d have same energy. In fourth shell you will see 4s, 4p, 4d and 4f all have same energy. Just saying second shell, right? Second shell means this one. This is second shell. Second s beta, 2s have 1 orbital and 2p have how many? 3 orbital. So these 4 have same energy, right? That's why answer should be 4. Similarly, if they ask in third shell how many are the Degenerate orbitals, so 1 here, 3 here, 5 here, 9 I will say. Degenerate orbital means orbital with same energy. Fine? Okay. Fine. Look at this question. They are asking which among the following can act as both oxidizing as well as reducing agent, right? Okay. So which among the following can act as both oxidizing as well as reducing agent, right? So in such question, what we have to do? You have to find element which is present in its middle oxidation state, not at the highest one, not at the lowest one. Because if something is present in its highest oxidation state, so it further can't be oxidized. If it can't be oxidized, so how it can act as reducing agent, right? And if something is present at lowest oxidation state, it can't be reduced. So how it can act as oxidizing agent, right? So in this case, if I say Here carbon is present in which one? +4, maximum. Sulfur -2, minimum. Chlorine 0, okay. Nitrogen how much? -3. Minimum, maximum. Chlorine is present here in 0. So chlorine can go to -1 also, can go to +1 also, +3, +5, +7. So chlorine can do oxidation as well as reduction, so it can act as oxidizing as well as reducing agent. If something is present in its maximum oxidation state, then it can never act as a reducing agent. And if something is present in its lowest oxidation state, it can never act as what? Oxidizing agent, right? That's why. So be careful about these questions. Now the next thing is, which among the following can act as both oxidizing? Okay, it is the same question. Point. The molar ratio of CH4 and O2 in a mixture containing equal mass of both. Very easy question. Equal mass. You can take any mass. You can take mass XX. Okay. If I say weight, I am having two things here. CH4 is given and O2 is given. Weight I am saying. You can take x gram, no issue. You can find a mole now. So x by how much? 16. X by how much? 32. It's moles, right? So if you see beta here, so cut it down. How much coming? 2 is coming. So 2:1. So molar ratio how much? 2:1, right? Okay. Same weight is given, but moles ratio are different. X by 16 moles of CH4, X by 32 moles of what? O2. Okay. Good. Now the next thing is, they gave us N25. Okay. They are asking the following. This line belongs to which series? The given line belongs to which series? Fine. Now, bache, look at this carefully. It is going from 5 to 3. Going to 3, na? It decides. N1 decide the series. If N1 is 1, Lyman, N1 is 2, Balmer, N1 is 3, Paschen, N1 4, bracket, and N1 5 means what? P-fund. Very easy. So 3 means which one? Paschen. 1 means which one? Lyman. 2 means which one? Balmer. And 5 means which one? P-fund. Right? If I am saying electron is jumping from 10, imagine jumping from 10 to 5. So it belongs to definitely P-fund series. And after P-fund, if N1 is 6, it is Hummerfee. But not in the NEET syllabus. Up to 5 is fine. I am saying once again, N1 is 1, Lyman series, N1 is 2, Balmer series, N1 is 3, Paschen series, N1 is 4, the bracket series, N1 is 5, P-fund, and N1 is 6 means Hummerfee, which is not so much required, right? Okay, easy. The correct order of electron releasing tendency of the given elements. You can answer this question with the help of which one? You can say electrochemical series, or if I give you the value here, you can easily see. It's very common matters. Normally they gave the values to us, but here they are very common atoms, elements you can say. If you look carefully, E naught of Ag plus to Ag is 0.80 volt, and E naught copper plus to copper is 0.34 volt, and E naught of zinc plus to zinc is minus of 0.76 volt. It is their Rp value which we can see in the electrochemical series. If I want to write their OP value, just reverse way. If I say E naught, Ag become Ag plus, minus of 0.80 volt, right? Here, E naught of copper give copper 2 plus. This value is given as minus of 0.34 volt, right? And next thing, if I am saying E naught of zinc, give us what? Zinc 2 plus. This value is given as 0.76 volt. Electron releasing tendency means which will oxidize itself, right? So here you see Zinc have positive OP, means it is interested in what? Oxidation. If it is interested in oxidation, so it have high tendency to release electrons, right? This one maximum OP, then this one, then this one. Very less OP means very less chances to release electron or high chances to gain electron, right? So by this order we can say here, electron releasing tendency if I am talking about, so zinc, then copper, then silver, right? If you ask electron accepting tendency, then I will say tendency accepting, I am saying Ag plus, copper 2 plus, and which one? Zinc 2 plus. Electron accepting, right? Right, it is electron accepting tendency. Clear? Okay, that's it. I'm saying once again, higher the Rp means higher the chance of reduction. Higher the OP means higher chance of oxidation or higher the interest in oxidation. If you connect two electrodes with the electrode with the higher SRP act as cathode and the electrode with lower SRP will act as anode, right? Or reverse I can say electrode with higher OP will act as anode and electrode with lower OP will act as cathode, right? The next thing is average atomic mass of element having two isotopes they gave, right? Fine. What is the formula to find the average atomic mass? Right. For those elements which exist in isotopic forms, we can say average atomic mass. It's mass of that isotope into the percentage divided by 100. Like here, it exists in two isotopes. The first one is its mass 20 and its percentage how much? 90. Plus the other one is mass 24, abundance definitely how much? 10 divided by 100, right? So how much coming from here? 90 into 20 how much? 1800 and plus how much? 240, right? So what's coming finally? Definitely from here 1800 plus 240 divided by 100, right? Means you can say from here 2040 divided by 100. So means 20.40, right? Or you can say 20.4. Fine. Average atomic mass is summation of the mass of first isotope into its percentage plus mass of the other isotope into its percentage, right? Divided by 100. If they don't give us percentage, they give us mole fraction. This way also we can find summation of mi xi, but here xi is just mole fraction, not percentage. If they give mole fraction, then there is no need of 100. If they give percentage, then divided by 100. Okay, so see the difference. Good. The next thing is from the Raoult's law. Okay, what they are saying here. If P naught A they give 40 mm and they gave P naught B also, they are saying in vapor phase. Okay, let us understand first of all. They are asking us YA. What is YA? What is YB? YA is PA divided by PT, means PA plus PP, right? And what is YB? It's PB divided by PA plus PP. Fine. So they have given to us what? They have given P naught A, they have P naught B. From an ideal solution, calculate the mole fraction of A in vapor phase in solution containing equal moles of both A and B, right? Equal moles. If Na and Nb are same in the liquid phase, then I can say XA, mole fraction of A and B also what? Same. And how much will come? half half. So we can say PA is easy to find. PA is XA into P naught A. P naught A how much? 40. How much coming? 20. So what's coming? P naught B. PB, sorry, half into 60, 30. Right? Now we know the value. PT is coming 50 mm of Hg. So what's YA beta? YA is 20 by 50. And what's YB? It's 30 by 50, right? Easy to find. You can see. So what's coming from here? It's coming how much? 0.4 and 0.6, right? It's asking for A, so 0.4 you can say, right? Be clear. XA, XB are the mole fraction of A and B in liquid solution, and YA, YB are the mole fraction of A and B in vapor phase, right? Vapor phase means when you make the solution, here A and B are present, so their mole fraction is XA, XB. And here in vapor phase we also have what? A and B in vapor phase. Vapor phase, what is it? YA and YB. This way you can go. Fine. That's from Raoult's law. Simple question. Calculate the mass of. Okay, you can see beta. Lambda equals to h by mv. From there you can find the mass. But still, little. You can apply this lambda equals to h by mv. Lambda h v. You can find v. The correct option for a mixture of benzene and toluene. Benzene and toluene makes what? Benzene, toluene makes ideal solution. For ideal solution, delta H how much? For ideal solution, I say delta H is what? 0. Delta V is how much? 0. And I will say, remember, delta S always more than 0 and delta G always less than 0. This is common in every case. This is common in every case. What I mean by this, it means you have ideal solution, non-ideal solution, non-ideal with positive deviation, or non-ideal with negative deviation. In every case, these are same. What change? This thing will change only. In non-ideal solution with negative deviation, delta H is less than 0 and delta V less than 0 for negative deviation. Whereas delta H will be more than 0 and delta V will be more than 0 for which deviation? Positive. But these things remains what? Same. So, benzene, toluene are both same type of things, so they make which one? Ideal solution. And if they make ideal solution, then definitely this should be 0, this should be 0, this should be positive, so only one thing remaining, this should be negative. Only this is correct, right? So be careful. For every type of solution, delta S is more than 0 and delta G is less than 0, right? Entropy will increase and Gibbs free energy will decrease in all this type. Mainly I am talking about ideal as well as what? Non-ideal with positive deviation or negative deviation, right? The number of significant figures in this one, right? So we know that all non-zero are significant, zeros in between non-zero are significant, 0 right side will be significant if there is decimal in the number, right? So in this case, if you see, we have 0. We have 0 here, it's where? In the right side. You see carefully, it is on the right side, but we have decimal also, no? So we can count it. So how many? 4 significant figures, right? But if I see this number only, I am saying just 5, 0, 1, 0, then only I will count how many? 3 SF. Right side 0 will be significant only when there is a decimal. If there is no decimal, then right side zeros will not be significant, right Bache? Okay, good. Left side never significant. I am saying 0, 0, 1, 2, 5. So only 3 SF here. If I am saying 0.0120, so here how many SF? Here 3 SF. Left side zeros are never countable if decimal present or not, but right side zeros are countable if decimal present, non-countable if decimal not present, right? In a photoelectric effect, the kinetic energy of ejected electron depends on what? Okay, we know very well that EI, energy of incident photon, equals to E naught plus what? Kinetic energy, right? EI equals to E naught plus kinetic energy, and if you find kinetic energy from here, it is H nu I minus nu naught. Definitely nu I, more value of nu I will increase the kinetic energy, no doubt. More value of nu I will increase the kinetic energy. Fine. So frequency of radiation, yes, it affects the kinetic energy. Wave number of radiation, actually if you see, wavelength and wave number are connected. Wave number is what? 1 by lambda, and definitely lambda depends on what? Frequency. For electromagnetic radiation, what is the relation beta? C equals to what? Nu lambda, right? So lambda can, if lambda more, then wave number less, as well as frequency less. So all three are connected to each other, you can say. Wave number and lambda are reciprocal of each other, and wavelength and frequency are related to each other. They are also reverse way, right? So wave number or wavelength, everything will decide. Okay, can affect the kinetic energy. If you ask, sir, intensity can affect the kinetic energy? No, intensity will not affect. Intensity means if you put more number of photons on the photographic plate, then more electrons will eject. But electrons kinetic energy, per electron kinetic energy will not change. Kinetic energy of ejected electron will depend on the frequency of incident light, and how many electrons will eject, it depends on the number of photons falling on the plate, or you can say intensity of the light, right? This we can think. Okay, the next one we can think now. The tank used in the scuba divers filled with air diluted with definitely helium, nitrogen, oxygen we carry in our scuba diving to avoid bends, to avoid making of bubbles in our blood vessels. Because if you take pure air or pure oxygen in the cylinder and you are going downside, so solubility of gas will be affected very highly with the pressure. Because if you go down in deep sea, the pressure increases very much, so solubility of gas will increase very high. But when you come upside, solubility of that gas will decrease very fastly, right? We don't want that, because if gas will be soluble, goes inside the blood, come outside the blood very fastly, it will create bends or bubbles in our blood vessel which can cause death. So we use helium. Okay, we take a mixture of helium and nitrogen and oxygen, right? Helium almost 11.2% around. Volume of 11 gram of CO2 at STP. Okay, they gave us weight. From weight they are asking volume. So we get the moles and moles to volume. Weight 11 gram. I will divide it by how much? 44 gram, na? So 11 by 44. How many? 1 by 4 moles. Now 1 by 4 moles, or you can say 11 by 44 moles into how much? 22.4. So what coming? 4. 5.6. So what is coming? 5.6 liter. Right? Easy to find. Okay, bache, the next one. The energy of 2s orbital is minimum 4. If you see carefully, we understand a little bit with the logic. I have here atom, and here imagine it is first shell, second shell. I am talking about 2s, right? If I have potassium here, so I have 19 protons. I have 19 protons. 19 proton, okay, energy. We consider that at infinite shell, energy is how much? 0. At infinite cell, energy is how much? 0. So if electron will come closer in an atom, it feel attraction from the nucleus, and that attraction cause release of energy. That's why we take energy negative in these shells, in orbits, right? 19 protons will strongly attract the electron in 2s. So more attraction will release more energy. If energy released more, the remaining energy become what? Less. I am saying again, more the attraction, more the release of energy, so remaining energy become what? Less, or I can say more negative. They are asking minimum, so definitely I will go for which one? Potassium. Or actually Bohr model is applicable only for one electron system. Otherwise, so we can say that now energy is what? Proportional to minus of z square by n square. Okay, this is definitely Bohr model applicable only for what? One electron system. Just to understand, I am saying a little bit here. More z will give you more negative. More negative means energy is what? Less. But logically, it is the reason behind it. More protons attract more, that attraction release more energy, so energy remaining become what? Less, right? So in these questions you can see, higher the atomic number, lower the what? Energy. If you are comparing the same shells or same, I will say, subshell in different atoms, right? Okay. The next one is, they gave the reaction and they are asking order of reaction. Okay, so rate expression or order we have to see now. What do we have? It's P and Q, right? What do we have here? It's 0.2, it's 0.1. So first of all, see very carefully. Here, in these two cases, or I will say, in this case, this is what? Constant. Q is constant. And here to here, I am doubling the what? I am doubling the P value. I am doubling the P value. I want to find its power, alpha. I am doubling the P value. I want to find alpha. You see, rate becoming how many times? No change. So one time I can say. So alpha coming what from here, beta? 0. Because 2 power 0 is what? 1. As I am doubling the P concentration, rate remains constant. So P amount is not affecting the rate. So it is independent from that, right? The next thing, if I say now here, okay, now in this case if you see beta, here in 2 and 3, P is constant and I am doubling the what? I am doubling the Q amount. On doubling the Q amount, rate become double. On doubling the Q amount, rate become double. So from here I can say beta how much? 1. So means P power 0 whereas Q power how much? 1. So overall beta how much coming? 1. Rate expression, if I write, rate expression is coming K into how much? P power 1 and Q power, P power 0 was there, na? Q power 1. So overall order how much? 1. Because order is sum of the power of the concentrations given in the rate law expression. Fine? Okay, look at the next one. Okay, good bache. So the next thing is enthalpy of reaction they are asking and they gave us delta U. Fine. Again beta easy. For the conversion of 1 mole of SO2 to SO3. Okay, reaction is I have 1 mole of SO2 and I want to make 1 mole SO3. Fine. How you can make it? I will take half O2 for this and everything is gas here. They can mention, but we know this, all are gases. What is delta Ng? 1 mole here minus how many moles here? 3 by 2 moles. So minus half is coming. Delta Ng is minus half. Delta H we want to find. Delta U beta. Delta U how much? minus x, okay, plus delta H is delta U plus delta NGRT. Now, what is delta NG value? Minus half RT. Are they giving some values or just R they are saying? And T, how much they are giving beta? 300, right? Fine. So if you solve delta H coming how much from here? Minus x here, and from here also minus is coming minus 150 R. Fine. So this way you can solve simply. Relation of delta H and delta U is very, very important. Every time they ask one question from here in thermodynamics, delta H delta relationship, delta G and work done question are very, very important, and Hess law also. Now, okay, they give the reaction. The partial pressure of A2, B2 are given here, and the total pressure is 1.6 atm. The value of Kp. Okay, fine. So that way they are trying to give us the values. The partial pressure of A2 they gave 0.2. The partial pressure beta of B2 0.4. Total pressure is how much? 1.6. So 0.2 gone, 0.4 gone. How much remaining? 1. So its pressure how much? 1. Now you know the Kp expression. Kp expression is pressure of AB3 power 2 divided by pressure of A2 into pressure of B2 power cube, right? Pressure of AB3 beta, we can see it was 1 square and divided by 0.2 power 1 and divided by 0.4 power cube. So easily you can find from here, right? That's it. What is coming from here? 0.4, 0.4, 0.4 beta will come from here how much? 0.2, and it is giving 64 and 3, 0.064. You multiply here, okay, easy to get. From here 3 decimal, here 1 decimal, 4. So 128, so 0.0128. Okay, second answer. Easy. Now, they have given some statement and we have to match the following. What they are saying beta in the first one? The first one is only 2 electrons may exist in the same orbital with opposite spin. It is given by which beta? Pauli's exclusion principle. Very easy to find. In the ground state of atom, the orbital are filled in increasing order of energy. Find very easy again. Which one? Bohr rule. It is impossible to determine the simultaneously exact position and momentum of electron. Definitely Heisenberg uncertainty principle. And the electron in the hydrogen atom can move around the nucleus in a circular path over beta orbit, given by Bohr model for hydrogen atom, right? Actually Rutherford also said same thing, that electron will revolve around the nucleus in an extranuclear part, right? But the shell discussion, orbital discussion, all these done by shell and orbit, stationary path discussion done by Bohr model. Okay, easy. Now, the correct order of number of atoms present in a given sample. Fine. They gave here what they are giving beta as volume. So 22.4 means how many? 1 mole. 1 mole N2 means how many molecules? Na molecules. Avogadro number of molecules. 2 gram. 2 gram means 2 by 2. Again I am saying 1 mole H2. 1 mole H2 means beta how much? Na number of molecules again. Now 6.022 10 to the 23. So many molecules divided by Na beta. Again 1 mole is coming. So Na molecules. This will give us mole, na? This give us mole. Actually, if you see carefully, in every case, indirectly they are saying we are having 1 mole. Here also 1 mole. And here also what? 1 mole. If moles are same, definitely molecules are same. If moles are same, molecules will come same, because mole into Na give us molecules. Maybe atoms can be different because atomicity also comes, but the molecules will be same. So we can see easily beta what is coming. All are same. Here I used V by 22.4, W by molar weight given particles by Avogadro number, right? Which among the following mixture form the maximum boiling azeotrope? Okay, so beta you see very clearly alcohol plus water always make positive deviation solution, right? So that's why it will make minimum boiling azeotrope. Benzene told me make which one? Ideal solution will not make azeotrope. Hexane heptane make ideal solution will not make azeotrope, right? What left here? Acetone plus chloroform. It make a solution with negative deviation, a solution in which solute solvent have more stronger attractions than the solute or solvent will have negative deviation, and will make which one? Maximum boiling azeotrope. The maximum boiling azeotrope, or I will say azeotrope, can't be separated using the fractional distillation, first point, and the maximum boiling azeotrope will have boiling point more than the both the components, and minimum boiling azeotrope will have boiling point less than both the components, right? It's a very important point. And these solutions making azeotrope can't be separated by the fraction distillation. Okay, good. The next thing is equilibrium constant for the given cell reaction is given. Okay, they are asking by giving E naught cell, right? But we know that the E cell, last equation, E cell equals to what? E naught cell minus 0.0591 by N log Q. At equilibrium, E cell becomes 0 and Q becomes equals to Kc, or you can say K equilibrium. So what will come here, you see carefully, coming E naught cell equals to almost 0.06 I can take, because it is almost 0.6 by N. But what is N value here? 2, right? What left? Log Kc. So E naught cell value given, so we can find from here log Kc. Log Kc is coming, E naught cell is 1.1, 2 will go upside, divided by 0.06. So this value is coming, and whatever come from here, so imagine this is coming log Kc into x, so equals to x coming. So what is Kc beta? Kc is 10 power x. Okay, this way you should know this relationship. This relationship, you can say E naught. This is our solved term. If I write completely, it was RT by NF. It was ln Q here, right? If I solve it by taking temperature 200 Kelvin, then it come what? 0.0591 and here what? Log Q. Okay. R value you can put here 8.314, T value I took 298, F value 96500, and I made ln what? I made ln log. So what I used 2.303. So by after all the calculation, this number comes actually, right? Clear? And remember this relationship, very important. And one more thing, if I say here relationship, we know very well that delta G equals to delta G naught plus RT ln Q. At equilibrium, delta G becomes 0, no delta G naught. So what comes from here? Delta G naught equals to minus of RT ln Q, or I will say K here, K equilibrium. Or you can say delta G naught equals to minus 2.303 RT log Q. Or I can say, sorry, K equilibrium, right? So this relationship or this was the same only. coming just by solving each other, because delta G naught is what? Minus NFE naught. Okay. 50 gram of CaCO3 decomposed to give it a what? A small stoichiometric question. CaCO3 decomposed to give CO and CO2. Stoichiometry is very much clear. If I go weight wise, we know that it's 100 gram will give us how much? It's 56 gram, it's 44 gram. Now they're taking how much? 50 gram. 100 give 50, so beta 50 give how much? 28 and how much? 22 gram. Right? That's it, easy. Okay. Okay, formation of methanol from the bromethane depend on the orientation of reactant molecule, right? If you see the last topic, collision theory, in that they discuss about the orientation also. Rate of reaction depends on many factors, and one of this is P, orientation factor. One is Z, collision frequency, and one is e to the power minus A by RT, showing the fraction of molecules having kinetic energy more than what? You can say threshold energy, also reactivation energy, and you can say it is showing the fraction of molecules having energy more than threshold energy. Okay, so orientation also very important, right? If molecules are attacking on each other with proper orientation, then only reaction will take place. Only collision is not enough, only energy is not enough, orientation also important, right? So if you remember SN2, in SN2 attack always takes place from back side. If nucleophile will attack from the front side, then reaction will not make product. That's what they are discussing here. Formation of methanol from bromomethane depends on the orientation of reactant molecule. Yes, they are talking about SN2 here, right? Yes, it depends. The only proper orientation of reactant molecules leads to the bond formation. Yes, definitely both are right only. Okay, good. The enthalpy change for the given reaction beta is given to us. The enthalpy of formation they are asking. If you see carefully, enthalpy of formation, I will make only 1 mole. Enthalpy of formation include the energy released or absorbed when you made 1 mole of compound from its simplest constituents in the standard state. I will make 1 mole of methanol. Definitely I need 1 carbon here, I need half of O2 only, and I will need beta what? 2 of S2. This reaction's delta I want to find, and what they have given to us? They have given here 2 mole. When you took 2 moles, so total energy release how much? Minus 477. So for this much, how much better? Minus 477.7 to divide by how much? 2. Or I can say, if I am dividing the equation by 2, so delta H also divided by 2. Right? Simple characteristic of delta H. Because delta H is which property? Delta H is extensive property. It depends on amount. If you will make 1 mole, different heat will release. If you make 2 moles, definitely different amount of heat will release. Right, bache? Good. Fine. If the rate of reaction doubles on increasing the concentration of X by 8 times the order of reaction, the rate of reaction doubles on increasing the, okay, they are saying rate become double on increasing the concentration of X by 8 times. So I have to find alpha. But alpha how will come? 1 by 3. Rate become how many times? Right here. You increased concentration how many times? Put here in power alpha. Right? Easy. 1 by 3. Next thing, the variation, the given variation of psi square they are saying beta. In this they are saying psi square shows the electron probability density, and here we are getting a node, right? It's node na, it's one of the node. So which orbital, 1s, 2s, 3s, 4s, which orbital have one node, one spherical node I will say. Yes beta. Which one have? 2s. 2s have one spherical node. Okay, that's why you can find this graph easily. If you see, this is 1s without spherical node. In 2s we have a node, and then again electron comes. So if we explain this graph, you see carefully, electrons are high in the center. As you are going away, electrons become less. Node comes. This is node. So when node comes, electrons become 0, almost 0. When you go away again you start increasing and finally decrease, right? So it is showing one node. One node is present where? In 2s. How I can say? Because formula is n minus l minus 1. What is n value? 2 minus beta l value how much? 0 minus 1. So 1. Okay. Monobasic acid among the following. Monobasic acid means which gives only how much? One hydrogen, right? So what do we have beta here? Which, or they can ask which one have n factor 1. So if you look at this beta, HCPO2. This is HCPO2. They are saying H3PO2 only, na? Fine. H3PO2 I am making here. Okay. H3PO2. This is H3PO2, which have n factor 1 and can give only one hydrogen. H3PO3, n factor 2 can give 2 hydrogen. H3PO4, n factor 3 and can give it a how many? 3 hydrogen, right? As to the 4, so we know very well, it's very easy. N factor 2 and give 2 hydrogens, right? Clear? Easy. Right? Fe3O4 is a mixed oxide. The oxidation state of Fe. So it is a mixed oxide made up of 2 oxides actually. Fe3O4 is nothing actually. It is a mixture of FeO and Fe2O3. Right? If you combine both of these, Fe how many? Total Fe3. O and O3 Fe3O4. That is the actual thing here. And separately if you want to find, you can say in this Fe beta how much? Plus 2. In this Fe how much? Plus 3. So plus 2 and plus 3 you can take. Average you can find. If they ask average, then I will apply formula directly on Fe3O4. I will say 3x 4 into minus 2 equals to 0. Average you can say it's 8 by 3. Okay, but individually if you want to find, then you have to find separately. Okay, good. Okay, little fact based question. We have to tell the order of a reaction, right? Just from NCERT beta, if you have H2O2 and I minus here, they said in the NCERT the rate expression is telling us that K H2O2 power how much? 1 and I minus also power how much? 1. They are saying it is first order with respect to H2O2 as well as first order with respect to I minus also. So order is 2 definitely. So I will find which one? This section, which one? Second order. You can say reaction. Very common reaction again I will say. If you are taking excess of water, then hydrolysis of sugar or sucrose is which order? Pseudo first order reaction. Ammonia decomposition which order reaction? 0 reaction on platinum surface. And this one hydrogenation, what's left? First order reaction, right? Little bit fact based also, just from NCERT. Okay, by looking at the reaction you cannot tell the order. Okay, it's tough if you have not seen it in the NCERT, because order is totally experimental term. So at least you should remember some reaction which are given in NCERT chemical kinetics, right? The equilibrium reaction is not influenced by addition of argon at constant volume, right? Beta, there are two cases, addition of inert gas if I say. We can add inert gas, first of all, one part is at constant volume. At constant volume, so always you say no effect. If they say you have to add inert gas at constant pressure, you add at constant pressure. In such case, to keep pressure constant, I increase the volume of vessel, and so that we have to go where gas moles are more, right? Now see the question what they are asking. They are adding argon gas, inert gas at constant volume. They are adding at constant volume. So we know that at constant volume though, it will not affect the partial pressure of given things in the reaction. So no effect will come always. So you can say no effect in all the cases. There is not a big deal. But by chance if a question comes, when there will be no effect at constant pressure, so I will choose which one? I will choose third one, or sorry, not third one, second one, because here there is no gas mole difference. Na? They made it easy because they gave, we are adding at constant volume. At constant volume, the never effect will come on equilibrium reaction. But if they give at constant pressure, then I have to go where gas moles are more. But in this case, second option, gas moles are same in both sides. So then also effect will not come. Okay. Superconductors have zero resistivity, right? Little physics thing, but resistivity is zero, resistance is zero for superconductors. Conductivity of electrolyte solution depends on temperature. Definitely metallic conductors as well as electrolytic conductors, conductivity depends on temperature. Definitely NCERT first page you see. The graph correct for zero order. We know for the zero order the expression is R by 2k. So definitely half-life will increase for zero order if R not will increase. So we can go for a straight line, right? Because it is what? Y mx. So what is m here if I say? What is m beta? M is 1 by 2k. Slope here is how much? 1 by 2k. Easy. Rate remains constant in zero reaction, but half-life increase with R naught. Okay. Enthalpy of transition of rhombic sulfur to monoclinic sulfur form the following. Okay. Fine. They are saying from where to where? Rhombic to monoclinic. I want to convert sulfur rhombic to sulfur what? Monoclinic, right? Sulfur rhombic to sulfur monoclinic. I need this one. I am calling it delta H3. How better we can get this? Rhombic is where? Rhombic is here. So I will keep it as it is. No change. So just delta H1. But to get the monoclinic that side, I will flip it, na? So delta H1 minus delta H2. Delta H1 beta how much value? Minus x. Minus delta H2 how much value? Minus y. Minus y become plus. Y plus, sorry. Y minus x. Okay, that we can find. Okay. Okay, now the next thing is the solubility of gases in the liquid increases with increase in temperature. Solubility of gas decrease with increase in temperature. We can explain it by 2 points. Whenever you mix a gas in liquid to make solution. Actually this is exo. This is exo. Exo will be favored at less temperature. If you increase temperature, reaction comes where? Backside. Backside means solubility will decrease. So low temperature is good for more solubility of gases in liquid, right? So first they are saying wrong. Osmosis is used in desalination of seawater. Yes, we can say that, but that is reverse osmosis. Osmosis process we are using, but we put external pressure using motor, and using the reverse osmosis we try to remove we try to purify the water. That is reverse osmosis instead of osmosis, right? The oxygen state of oxygen is KO2. But KO2, K to never exception, so K to +1 only. Oxygen how much? 2x equals to 0. So what's coming? X equals to -half. X minus half beta, oxygen in -half state means it is what? Super oxide. Normally oxygen have -2. When oxygen have -1, it is peroxide. -half means superoxide. So it is potassium superoxide. Okay, we use lead storage battery in our inverters, right? It's a rechargeable battery. If you remember the reaction also, the reaction was Pb plus PbO2 in acidic medium or sulfuric acid we have there. It makes PbSO4 plus water. It is the reaction during discharging, and we reverse it during recharging, right? The degree of hydrolysis of which is following independent of the concentration of salt. Okay, if you see it's a salt of weak acid with a weak base, here the formula is H equals to √kH. That's it. KH, sorry, KH, right? And there is no C here, there is no C, right? And how we find KH? KH we find by this one, KW, K into KB. And next thing, if you see the pH formula was, the pH formula is here, 7 plus half pK minus pKb. So this question also very common, that among the following salts, the pH will not depend on the concentration. So salt of weak acid, weak base, pH do not depend on concentration, you see, and there is no C, and here also there is no C. Okay, so the answer should be a salt of weak acid and weak base. In remaining cases, like in this case, if you see, this will be H √kH by C, but in this case there is no C, in pH also, in H also, because both ions do salt hydrolysis. So what KH comes? KH comes CH into CH divided by C minus CH, C minus CH. So CC cancel out. So C will not come. Fine. A current of 965 ampere is passed through AlClC, the amount of aluminium. Okay. The first we can use W equals to ZIT. What is Z for aluminium beta? 96500. What's I here? I is 965 ampere, and time they give 5 minutes, means 5 into 60. First law of first law of Faraday, very easy to find from here, right? You can cut it down from here. What's coming? 100. 1 0 I can cut from here. 1 0 remaining, and remaining can multiply here. Easy. The correct relation they are asking me. Just now we did in a few minutes back. We discussed about it, that delta G naught is equals to minus of what? 2.303. If you say here carefully, I am writing it again. Look, what measure you can do here? delta G naught was there, right? It was minus here RT, it was RT ln K, fine. Or I can put here minus of 2.303 RT log K. In this case, what is coming? Log K. Are they writing here something like this? Here, what mistake they are doing? They are putting here minus RT log K. So here the ln should come if they want to make it right. And here if they are writing, here what should come? Log. With this log comes, and without this only ln comes, because we use this number to convert ln to log, na? So means they are playing some trick here. So don't trap in that part, right? Now we come here simply. This is the part, right? Look at the first part. Now you can take this all out here. I can write here from this term. I can say delta G naught minus, if I take here RT, and here how much? Ln K. NT, I will take ln, NT ln. So what is coming? E power minus delta G naught by RT. That's it. Okay. So be careful with little points. Fine. The next thing, beta, the approximate percentage mass of HNO3 in azeotrope, again from NCERT, 68% HNO3 and water solution. Remaining is water only, na? It acts as what? It acts as azeotrope. Which azeotrope? Maximum boiling azeotrope, because HNO3 and water make a non-ideal solution with negative deviation, right? Okay. Law of multiple proportion is not applicable for. I told very clearly that law of multiple proportion you can apply on those molecules which are made up of same element. Like in this case, if I say, okay, this is made up of NO, fine, SO, fine, CO, fine. What is it? It is made up of S and O, and it is made up of what? N and O. In law of multiple proportion, all the molecules must be made up of same elements, right? Be careful about it. Okay, now we have this one, beta. You XeO6 they gave 4 negative and making it what? XeO3, and they are making what? F minus into F2. So you can balance it by the short trick, whatever you are using. Now let me check here. I divide in two parts. First I am taking here XeO6 4 negative. I will take downside. Then you will balance it. XeO6 4 negative, right? And we are making it XeO3. Fine. You want to balance it. Okay, we balance using the trick Aao Haryana Chale, right? So first of all, you balance atoms other than hydrogen and oxygen. First balance other atom, don't disturb the hydrogen and oxygen. The first other elements, Xe, 1 Xe, already balanced, no issue. Then balance oxygen. What is oxygen here? 6 oxygen. How many oxygen here? 3 oxygen. So I will better use what here? I will use here 2 to make how many oxygen? 6 oxygen done. No hydrogen, so balance. Now balance charge. How much charge here? -4. How much charge here? 0. So I will add here 4 electrons, so that total charge will be same. Getting my point? I balanced Xe first. Already balanced, it was there. Okay, sorry. I did something else here. Sorry, wait. It was Xe. O6 4 negative, and here we took XeO3. Right. Now Xe beta already balanced, right? Oxygen how much here? 6. Here 6 beta. How we balance the oxygen? Using water molecule, na? We took 3 water, right? I am saying once again, Xe balanced. Oxygen how many here? 6. To balance oxygen, I will use what? I will use Water molecules. So how many water molecules I will take? 3. Now 3 here, 6 here, right? To balance hydrogen, how much will come here? 6 of H plus, because there are 6 hydrogens. Now balance the charge. Total charge how much? Plus 6 minus 4. How much charge? Plus 2. Plus 2, and there is no charge. Here charge plus 2, and here there is no charge. So I will add over here 2 electrons, so that total charge will be balanced. First balance other atoms other than what? Oxygen, hydrogen. I balanced xenon. One xenon already balanced. Then I will balance oxygen. 6 oxygen here only 3. So I will add 3 water molecules, 3 oxygen comes. Now because this 6 hydrogen also comes, so I will use what here? 6 hydrogens, right? Overall balance charge I will see now. Charge was minus 4 plus 6. Overall charge plus 2. Charge 0. So whatever difference on charge 2. So I will add here 2 electron. Why? Because it is your reduction half. So it is coming left side. Clear? Now where do we go for the next part? We are taking F negative. We have F negative. And what do we have? F2. Right? First balance beta F. What's coming? 2. Right? There is no oxygen, there is no hydrogen, so nothing to do. Balance charge. Here F minus, minus 2 charge. Here how much charge? 0 charge, right? Here minus 2, here 0. So we will add here 2 electron to balance the charge, right? So we have balanced our oxidation half, we have balanced our reduction half, right? Now I will add both of these to get the answer, right? Here 2 electron, here also but 2 electrons. So easy to add both of these because there is no need of cross multiplying because both have same electron. Remember, if by chance electrons are different, then I have to cross multiply to balance this electron, or this electron must be cancelled out in my final equation. Right, bache? Clear? So we can see here, if we write the final equation, what is coming? If I write the final equation, beta, what is coming finally? It's coming Xc O6 4 negative 6 of H plus, and what do we have left side here? 2 of F minus, right? And this side we have XeO3 plus 3 water and what? F2. That's what we have to write. Now you can see it's balancing how much? 1, and definitely beta H positive how much? C, right? And water you can see its quotient coming how much? 1, it's a 6, it's 2, and water how much? 3. That's it. Fine, bache. Good. Yes, you can see option H plus how much? What is A? XeO3. 1 is there. What is B? B how much beta? F minus, so 2, and C how much? What is C? H plus 6. That's it. This one. Next one is the possible number of exchange of electron for a D5 configuration. Why D5 is more stable than D4? How we explain? Because it have a more exchange options. That's why electrons keep changing their positions, and in that exchange energy will release. More the release of exchange energy, more will be the stability, right? So if I say D5, this is D5, right? So this one can exchange position here, 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 4, here, 3, now here 2, and beta here 1. Total how many beta? Initially can do 4, then 3, then 2, then 1. How many coming? 10, right? Easy. So 10 exchange options are there. Okay, now they are asking units beta of concentration terms. So we can see here we have molality, so definitely mole per kg. Mole fraction definitely unit less because moles of A divided by total moles. So moles cancel out, there is no units left. Molarity, mole per liter. and definitely with a cryoscopic constant that are talking about Kb, right? What is Kb? Sorry, Kf, delta Tf what? Kfm. So from here you can find easily this one, fine. The visible spectrum of the electromagnetic radiation lies in between gamma rays and X-rays. You see, sequence is what? Sequence is C, G, X, UV, V, I, M, R. Cosmic, gamma, X, UV, visible, infrared, micro and radio, right? What they are saying, the visible spectrum of electromagnetics lies in between the, which is better? Lies between the gamma rays and X-rays. Gamma rays that are here, X-rays here, definitely visible is not in between them. Na? Visible is so here, it's not in between these. It's in between UV and what? Infra. You can say in between UV and infra, right? Each element has a unique line emission spectra. Definitely, every element have a different line spectra which is used as its fingerprint identification, right? Okay, the next thing is average oxidation state of carbon in the C3O2 is 4/3. Yes, we can say that. We are having C3O2. Apply the formula 3x 2 into minus 2 equals to 0. X coming 4/3, right? But if you say C3O2, but C3O2 is actually a carbon suboxide. It have different structure. It is not a mixed oxide. So if you break the bonds here, I will break its two bond. What come here? Minus 2 plus 2. Break the bond. 0, 0. How much here? 0, 0. How much here? Plus 2, minus 2. So I will say carbon here is how much? Carbon is plus 2. Carbon is 0 and plus 2. So it is carbon suboxide. Here there are no two oxide mixed. Here we have carbon plus 2 as well as what? Plus 2. And one is 0. So average is coming how much? 4/3. Fine. Atom with same atomic number but a different mass number is known as isotope. If you look better, most simple example, 1H1, 1H2, 1H3. What are these? Isotopes. Whereas if I take argon 1840, potassium 1940, calcium 2040, what are these? These are isotopes. What are these? Isobars. They are saying isotopes, atom with same atomic number, right? 111, but different mass number are isotopes. Fine. Now, isobars are the atoms with different mass number. No, isobars are same mass number, different atomic number, right? That's why they are doing mistake here. The empirical better. The molecular formula is C6H12O6. Definitely I'll cut it by 6 so that C1H2O1 is our empirical formula, right? It's very easy to find. Number of atoms present in 0.1 gram molecule. Here it is important little bit. Gram molecule means actually mole. Gram atom also mole, gram molecule also mole, gram ion also mole. It is not the weight, gram molecule is mole. So I can say I am having 0.1 mole of ammonia, right? 0.1 mole ammonia, but I mean how many molecules? 0.1 into Na. 0.1 into Na. They are asking atom. So every molecule have how many atoms? 4. So 0.1 into Na into 4. It is a real. Okay? You can say 0.4 Na, right? Remember again, I am saying gram molecule means mole. Gram atom means mole. Gram ion means also mole. If I give example here, I can write I have 1 gram atom of nitrogen It means 1 mole of nitrogen. I can say I have 1 gram. I should write completely. Sorry. Okay, so what I am having? I am having 1 gram atom of nitrogen, or I can say I have 1 gram molecule of CO2, because it's a molecule, na? So gram molecule means mole. Gram atom also what? Mole. Or I can say I have 1 gram ion of Na plus. So all things show mole, mole, mole. Just saying different way. So this is it about today's class. So we discussed most of the important questions. I hope this will benefit you, right? So just focus on every question, see how I solved all the questions, and definitely these are the most important questions from every chapter, right? And I am saying once again, from the physical chemistry only 6 to 7 numericals will come, not more than that. So don't think physical chemistry is like there are many numericals and you are scared of that. No, only 6 to 7 numericals and 1 line numericals. They will not ask you very lengthy or very tough numericals, because NEET is completely game of time. They can't give you a question which you have to solve in 4 or 5 minutes. No, 30 seconds max to max, 1 minute max to max. They can't give you a question which takes more than 1 minute, right? So I hope this video will give you benefit. Okay, thank you very much.